Welcome everyone, and thanks for joining this webinar. Today, we would like to cover how IoT is driving energy savings in retail. And the Zenatix CEO and co-founder Rahul Bhalla is joining with me in this webinar. I'm Abhishek. So before we get started, a couple of housekeeping items. There's going to be a 1-hour session broken down into a 45-minute presentation from Rahul and then a 15-minute Q&A following it. For the audience, you will need to type your questions in the Q&A panel of the webinar at the bottom. Anytime during the 45-minute presentation session, and we will take the questions at the end of the webinar. The slides and the webinar recording will be emailed after the session to all the attendees. And post the webinar, you will be receiving a short survey at the end of the webinar. So we'll love to hear your feedback on the webinar. So quick introduction about Rahul, who leads Zenatix. So he's a co-founder and CEO at Zenatix, and Zenatix provides IoT-based automation solution targeted at delivering energy efficiency, better occupant comfort, and improved asset management for commercial buildings. At Zenatix, he has developed and found relationships with 50+ enterprise customers and ensured value delivery to customers both in India and Middle East. Prior to co-founding Zenatix, he built KPO businesses at 3 of the largest outsourcing companies. And Rahul is a graduate of IIT Delhi. He started Zenatix along with his batchmates in 2014. That's about Rahul. I would like to hand over the session to Rahul from here on.
Sure. Thank you so much, Abhishek. Good evening, everyone. It's my pleasure today to speak with all of you. And thanks for taking the time to join this webinar today. So we have today guests from both India as well as Middle East. So these are the two geographies from where we have the guests, and especially thanks to people in India who are actually we're heading into a long weekend, but still they've taken time to join this webinar. So welcome everyone once again. So let's talk about how energy is important and what can be done about energy management, particularly in the retail sector. So this is really the agenda that I want to cover today. We'll talk a little bit about the retail market globally as well as in the GCC. Why energy management is critical in retail. I think all of us understand the importance of energy, but let's just emphasize a little bit on this piece. We'll talk about based on our experience working with several large enterprises in retail, that what are the challenges that are typically faced at such infrastructures, and how the IoT based automation is delivering value to retail stores. So that's really the focus on today's webinar. And of course, we'll talk about the benefits, quantified benefits of IoT based automation. We'll talk a bunch of use cases, and then sort of happy to answer any questions towards the end. So before we start, we would like to run a quick poll. Abhishek will help run that poll to just help understand the composition of the guests today. What do they do? It will just help us understand that. So Abhishek, let's just quickly run the poll. So it's really the poll question is type of organization that you either run or work at. Do you work at a corporate or an enterprise, an FM company, you're an MEP consultant or a PMC, or fall into the category of a BMS provider or an HVAC contractor or any other. So, we would just love if you guys, everybody can sort of, vote. Yeah, we'll just give you guys a couple of more seconds. I think we have a couple of people left. If they can also quickly press the button, that'll be very useful. Okay. So that sounds good. I think, we got a fair bit of a mix here. People from enterprises, MEP, you know, and, so I think it's a fairly good mix that we got. So I'm just going to close this window and then we can move forward. So there are roughly people split into three categories: corporate enterprises, MEP consultants, as well as BMS providers. So I'll just, share the results. So these are really the attendees. So as I said, there's a fair bit of a mix. So let's just quickly run through the session now. So I think, the first and foremost piece is that, the state of the retail market. I think it's growing globally. It's in the globally, the market is roughly close to about $25 trillion. And barring the 2020 cycle, we see a steady growth in this. That's true for the GCC region as well, where we have, steady growth coming in. The worldwide global retail sales are projected to reach about $26 trillion by 2022. So that's where we currently stand. Why is energy management critical in retail? I think COVID has taught us a lot of things. It has taught us to be be cost effective and lean. All of us understand that energy is the third biggest spend in retail, but the good news is that it's a controllable spend, right? And when we look at automation of assets which consume energy, the automation can deliver 10 to 20% energy savings. This is again coming based on our experience. And therefore, because it's a spend which accounts to about 10 to 20% of your overall operating cost, you can actually improve your EBITDA margins or bottom line by 1 to 2% through energy savings. So it's a very, very tangible outcome that you can drive for your enterprise, by saving energy through automation. Now, if we look at the solutions for retail and small buildings, if you just segment the market into two parts, one is small buildings / retail, another is large buildings. It's in the small buildings and retail, which we would quantify as less than 100,000 square feet in size. The traditional BMS systems, which were for automation into these setups, they were not developed for this particular segment of less than 100,000 square feet. They were always developed for large buildings. And therefore, this particular area is deprived of automation, not just in India, GCC markets, but globally, it's a white space. There is a need for enterprise guys, retail chains, multiplexes, co-working spaces, warehouses. These are a bunch of examples which are massive infrastructures if you look at the the distributed nature of them, and they need respite on energy savings. There is really no solution, but IoT is now sort of making headway into this space, and we are really the market leader in this space with our IoT based automation solutions. Of course, the large commercial buildings market with greater than 100,000 square feet, it's traditionally addressed by the BMS system. Now, looking at the type of retail stores, are small, medium, large, starting from as small as 300, 500 square feet, going up to about 60, 70,000 square feet. And what really varies is maybe the type of air conditioning. In the much smaller size stores, you will have high wall split air conditioners. In the medium size, you may go into ductable units or cassette units, and or VRV units to some extent. And as you move to the larger sides, they may have multiple of such units or VRVs or even chillers. These could be high street stores, these could be mall-based stores. And I think the good news is that IoT can control all of these infrastructures. So lighting, HVAC, ventilation, all of them can be controlled through IoT in a very, very cost-effective way. And now, I think before we talk about some of the challenges in the retail infrastructure, specifically from an energy and other standpoint, we would just run one more quickly another poll. which will help us understand that, how do you relate to these pain points. Abhishek, you have, I think this, I can see the screen, but the previous poll is showing up.
No. So I have stopped the sharing, and
Okay.
I will run the second poll. So let me do that, right? Second pool is also launched.
Yeah. So if you guys can, share with us, what is the biggest pain point that you personally relate to? Is it high energy costs? Either you face it directly, or, what you hear from your customers, maintaining temperature compliance, frequent asset breakdowns, or any other, right? So I think if you guys can quickly press the button, that will just help us, understand the pain points before we sort of go further. We'll give 30 more seconds, I think, but half of the people have voted. So I request the remaining guys also to sort of vote as well. Got about 75% people voted. Come on, guys. I think let's just we'll give maybe 20 more seconds. All right. So if we just look at, so I'm just going to end the poll. Majority of the people have already voted. And I can quickly share the results. So I think, by far energy is the, this is our understanding as well. About 73% of the people say high energy cost is the major pain point. Temperature compliance, doesn't seem to be the pain point. And then some people have either other or, and at some point, I think, when you guys fill the survey form, you guys can help us understand what is that other challenge that we got in retail. But, I think, it's sort of, and that's the topic of today's session, that, how are we going to drive energy savings, right? So this is, our understanding. While I think energy is, I would certainly agree with the fact that high energy costs, and high energy cost is typically, I think as long as it's a genuine cost, because, you are running air conditioning, lighting system for the guests to come into retail. But what you can certainly control is the wastages. Wastages can happen for multiple reasons. Equipment is operating outside of the operating hours. People turn on much earlier than required, or forget to switch off equipment. Too low temperatures being maintained in certain area, or high diesel consumption, particularly in the Indian market. Poor power factor. So some of these things are, or equipment operating inefficiently, right? So that all leads to high energy cost. I think compliance is also another important factor, which, even if it's not a pain point, IoT, at a very, very incremental cost can deliver, understanding of compliance, both for customer comfort as well as for food safety. If you are a QSR or a food F&B outlet or a supermarket, the food safety becomes important. And then there is electrical health and safety risk, which could be other category, lack of visibility into solar operations if you have deployed some solar for sustainability reasons. So these are, a bunch of challenges that we have sort of come across, working with our customers. Moving on, I think, how IoT can solve problems. And, we'll talk about, what kind of, architectures are out there from an IoT standpoint. But really, the solution is split into three parts. There are energy-related interventions, there are compliance-related interventions, and there are asset health-related interventions, right? So a simplistic solution could be that you monitor first energy consumption, put simple energy meters, which are very inexpensive, at your grid supplies, at your diesel gensets, or if you have solar incomers. You monitor energy consumption in real time so that you understand, where the energy is being consumed. The tangible result of control is that you save energy. And what can you control? You can control air conditioning systems, lighting systems, exhaust fans, signages. These are really the major guzzlers. In case of, some food and beverage outlets, there could be other guzzlers like, fryers or, ovens, or, as long as they are on power. They can be high energy guzzlers. so they can be controlled through IoT, and all of this can be done in a central automated fashion, right? And then you have compliance. So one can monitor temperatures and humidity in your occupied areas, in your refrigeration units, cold rooms, chillers, freezers, uh, right? And some places UPS battery voltage is important, so that can be monitored. So that's all sort of falls under compliance. And then asset health, that how do you prevent breakdowns? How do you make sure that the equipment is operating in a healthy manner, right? So all of those things come under asset health. And again, what are the typical assets where you look for health? Air conditioning, refrigeration, exhaust fans, and DGs, right? So I think in retail, these are fairly the standard, loads that you have, and therefore they can be controlled easily. And this is how a typical system architecture looks like. You have your retail equipment, which is your HVAC, air conditioning systems and exhaust fans. You have refrigeration, you have power backups like diesel gen sets, or even power generators like solar, etc. You have your lighting and you have your glow sign boards, right? So what happens is that in IoT, we don't expect the customer to replace any of this equipment and say that it has to be a connected equipment. What we do is we will sit on top of this existing infrastructure. So you have your IoT sensors, IoT actuators, and the sensors could be temperature sensors, humidity sensors, battery voltage sensors, energy meters. There could be luminosity sensors. A lot of apparel retail, for example, they need to understand what is the light that is falling on the shelves, both from a customer satisfaction standpoint. So those are very, very easy in an IoT setup. And then you have actuators, which are really controlling. So you send something, you control something, and all of this is enabled through a controller or a gateway at the site, which is really the heart of the system. And this controller locally operates everything, and then it is also connected to internet so that you can get all of your sites. If you have 50, 100, 1,000, 2,000 retail outlets spread across a geography, all of them then come centrally on a platform. So today we have done that at more than 2,500 retail outlets in the country, right? They are all centrally controlled and managed for large enterprise retail guys. And on the cloud, you get central dashboards. And I think, a lot of people raise this question that, what if the connectivity goes down? And the answer is that, the systems still keep on working because the controller at the site is really regulating everything. So the control actions are seamless. If you're collecting data, the data will keep on getting stored within the controller. And once the connectivity is restored, it goes back to the cloud. So, and then that's where the expertise of an IoT service provider comes in, that, how robust and how scalable these systems are. What are the measures they have taken to make these systems? So for example, if we are on GSM connectivity, we understand the GSM connectivity is sometimes patchy. We provision dual SIM connectivity. We put battery backup for our gateways because the power quality sometimes is patchy. Voltage protections, all of those things are taken care of in building these systems. Then the question is, how are energy savings delivered by IoT, right? So we've talked about scope. We've talked about how the systems are architected, but how is the energy efficiency delivered, right? So I think really the two parts to it. One is automation, and second would be analytics, right? So automation, if you say that my outlet starts at 11 a.m., there has to be the right time to turn on your equipment, right? So we have seen places where air conditioning starts like 4 hours or 3 hours before the outlet starts because somebody came to clean the outlet much earlier, and the full blast air conditioning is turned on. So you can always set schedules. So for our enterprise customers, we go down at an air conditioner level, at a site level, and say this air conditioner at this site will automatically turn on at 9. Another air conditioner will turn on at 10. Another air conditioner will turn on at 11, depending upon the requirements, right? In supermarkets, for example, you have different areas. There are the vegetable sections which start way early in the morning. So you switch on only those sections, right? Yeah, the other apparel sections are sort of closed out at that time. So you basically do intelligent controls. You link controls with the operation. For example, an exhaust fan can be turned on based on the operation of a pizza oven, The oven switches on, the exhaust fan automatically turns on. So these are a lot of examples of controls, and that will stop your exhaust fans running all the time, or air conditioning being switched on much earlier or much later. So that's what the automation delivers. And then we have analytics, which is really fault detection and diagnosis based on the data that we collect. And this really, again, the way we deliver this is that every anomaly should be flagged. So we don't expect customers to analyze a lot of data because they don't have the time to do it. What we simply do is create a ticket in the system, right? So if your refrigeration doesn't have a good health, we'll create a ticket in the system. If the temperatures are low or high, which are beyond our control, if the air conditioning system is not working well, we will raise a ticket. So all of those things are great. So either everything needs to be actionable based from the IoT system. So either we control or either we raise a ticket for your team to address it. So I think that's how, and all of this then lead to tangible energy savings, which you can see in your energy bills. And based on our experience, because these IoT systems are cost effective, they're hardware light systems, the ROIs range anywhere from 12 to 15 months, which are kind of unheard in this industry. 12 to 15 months is a very, very good ROI. And that has allowed us to scale with more than 50 enterprise customers and 2,500 retail outlets where we operate today. And this is how the system works, right? So I was explaining you about automation versus anomaly detection. So you collect the data through the hardware, the data is transmitted to the cloud. The data is transmitted to the cloud via our gateways, where our engines run, ML and AI powered engines run. So which are really either doing a control action, or we are doing anomaly detection. So a control action will directly save energy, and an anomaly detection will create a ticket, which goes through a ticketing workflow, and that will lead to, and once these tickets are addressed, it leads to improved compliances and asset management. So you get better temperature and humidity compliance, and the customers can really monitor, sitting at a central level, what is my temperature compliance across all my guest areas, and the compliance could be defined as temperatures between 24 to 26 or 22 to 24, depending upon what you really want to maintain. So and then you can say, understand from the real-time data that are you maintaining 85% compliance, 70% compliance, or 90% compliance. So that's how the systems are set up. The benefits of an IoT based system, as I clearly said, it can deliver 10 to 20% reduction in energy cost. This is very, very tangible. So if some of our enterprise customers spend $20 million in power bills in a year, and we have been able to save 12-13% for them, which is $2.5 million a year. And this is very, very tangible for them. And as I said, it improves their bottom line by 1 or 2%. And the ROI for any such interventions is 12 to 15 months. It has also led to improvement in their temperature compliance, by 25 to in guest comfort by about 30 to 35%, and operational compliance by about 25 to 30%. So that's what we have seen. And we've also seen a reduction in equipment breakdown, because we are able to, and I'll give you a couple of examples of how we monitor equipment health. And we've seen that with our customers that their breakdowns have reduced by about 20 to 25%. I think one of the questions is that a lot of people talk about IoT. I think this has become a buzzword. I think the important question is that why is the world moving towards IoT based automation? The automation has always been around. There are BMS companies, Schneider, Honeywell, JCI, Siemens, who have been doing automation for many, many years, or rather many, many decades. Now, why suddenly people are talking about IoT? And I think one, and these are really the reasons. One, these are hardware light and software intelligent solutions. That in the traditional world, everybody tried to do everything on the hardware itself. A lot of processing happened on the hardware. So these were embedded systems. Now, you really need to do the basic stuff on the hardware, and everything can happen on either a gateway or the cloud. So which makes them very, very light solutions, which also reduce their cost, which basically makes them very, very cost effective. Second, they use a lot of wireless technology, right, which are very, very easy to deploy as well. And again, in turn, reduces the cost. So wireless technology. So as a company, we work on the state-of-the-art mesh technology. So if you are familiar with wireless, the traditional way of doing wireless is Wi-Fi. But the world is moving towards a mesh technology, which is, in a traditional wireless, you have, all your sensors talk to a central router. The way you have, your networking done at homes or offices, you need a router to sort of talk over Wi-Fi. But in a mesh, there is one node, transmitting data to another nearest nearby node. And that's how the mesh is very, very easy to set up. It is also, there is a lot of redundancy in the mesh, because, if you're not able to talk to a nearest node, there is another nearest node that you can talk to. And that's how the mesh is set up. So wireless technology is big in IoT, and it is very, very easy to deploy and give. So all our temperature, humidity, luminosity sensors are all battery powered, because this is a low power mesh. So these are, you can stick on a wall, no wires, doesn't disrupt the aesthetics. And the batteries, standard 2 AAA batteries, can last for 2 years, even if you are sampling data at a 1 minute resolution. So very, very effective technology. The other important aspect is that, IoT technologies, tend to be very, very OEM and machine agnostic. Now, what does that mean? If you are an enterprise retail customer, you have different types of equipment, air conditioning, lighting, exhaust fans, are therefore different providers. And within each type of equipment, air conditioning, you may have 5 different brands that work with you, right? Now, you can't afford to buy different systems from different brands. You still need an overlaying IoT technology, which can connect to all of them in a, OEM and machine agnostic way, so that the customer has only one single platform. So all our enterprise customers today just have our own platform, where they have control over their air conditioning systems, lighting systems. They control, manage, monitor everything, right? It doesn't matter which brand or which equipment that you have. So that's the biggest advantage of IoT. And then and these are plug and play systems. Plug and play basically means that, very, very easy to configure and commission. BMS systems take a lot of time to commission. These systems are IoT systems because they're lightweight systems. They're very, very easy to deploy. And so if you have to do 100 sites or two, so we typically deploy about 200 to 300 sites every month with a very, very, small team, because these systems are very easy to deploy. And finally, because of the way these systems are set up, value that they deliver and the cost that they carry, the ROI periods, as I said, anywhere range from 12 to 14 or 12 to 15 months. So that's why, the world is sort of really moving towards, IoT based automation. I see there are some questions coming up. So guys, please keep on, putting the questions. We'll go for another 15 minutes, and then we will open up the floor. Basically I'll help answer the questions. So I think let's now quickly go through some of the use cases. We've talked about, the scope. We've talked about how systems are set up. We've talked about how they are beneficial. So the first is visibility into operation. So as I was explaining, you can have all of your outlets onto a single platform. So today, if you want to know that what was my energy consumption across all my stores yesterday, in last 1 hour, last 1 month, it is right there, because it's all connected. You can simply log into a dashboard and see what is the energy consumption. You can compare yesterday's energy consumption with same day last week, same day last year, because you have a log of the data. You can slice and dice in whichever way we want. These systems are configurable. You can understand the temperature compliance. What temperatures are you maintaining in the guest areas, in your chillers, freezers? You can get, alerts for your electrical health and safety issues. And then all the reporting is fully automated for you, right? All the stuff that you were doing manually into Excel spreadsheets, now fully operated. On a click of a button, you can download an energy report for all of your sites for any period of time. So that's provides you a lot of visibility into your operations, right? uh, you can actually see how the controls are helping you. These are some examples I've taken. So on the first graph that you see is an air conditioning system. Without control, this was getting turned on at, let's say at around 10:30. The customer wanted to turn it, just 10 minutes before 11. So the schedule actually shows you, and this data, this area where I'm highlighting is really the energy saved. This area under this curve is energy saved. Similarly, you shut down much earlier than it was required. So it's very visible that, how you are saving energy. This is again staggering of lighting operation. You push it out and you switch off early. It's not really early, it's actually at the right time. So you are switching later because you are relying on people to really do it. And, people may or may not doing as per the standard corporate policy. And it becomes hard when you have 50, 100,000 locations. Similarly, this is an example of, asset health, where, a typical compressor, a refrigeration compressor, you see, a bad compressor is that it's always on, right? So I think one of the things that, we've seen from the data is that while a lot of places the temperatures are being maintained, but either the AC or the refrigeration unit is not in good health. So which basically means that there are no duty cycles happening. And so this is an example of a good compressor where you achieve a temperature, you shut down, the temperature goes out of the set temperature range, it switches on. This is a good behavior. And typically, at least 40 to 50% of the time, compressor is supposed to be switched off because it can just maintain that cooling. But we have a lot of places we have identified such, and because we have the real-time data, our algorithms can simply flag these things. So we are not expecting you to do this analysis. The system will automatically do that using ML AI algorithms, and we will create a tickets. For example, this is a graph of temperature compliance versus duty cycle. So everything which is here on the right-hand corner, which means that you are maintaining the compliance and you have good duty cycles. So, and these are the problem sites. Now, what we do is that we raise alerts and people, our customers fix those problems, and you will start gradually seeing these dots moving towards the right. So that's a very, very tangible way of looking at, how the improvement happens on a month-on-month, quarter-on-quarter boxes. We have one customer where we have 900 cold rooms being monitored in this way. And all those 900 cold rooms are now converging towards the top right-hand corner where you have the maximum temperature compliance at the least amount of energy. And that's where the power of data is. So that's one use case. Then we talk about safety. A lot of places we've seen the current unbalances across circuits. When you set up a new outlet, everything is good because the circuits are balanced. Over time, people switch, move loads from one phase to the other, especially the single phase loads, and that creates unbalances and lead to fire hazard issues. So, we track this, we will raise a alarm, whenever there is a significant unbalance that we see. And then, we go to the comfort zone, right? So, this is a good, we see the data, and that's what our mandate is that, so even ASHRAE, specifies that a good human body comfortable temperature is 24 to 26. If you want to define your own range, which is 22 to 24, that's fine, right? You just define that and, maintaining a good amount of humidity. So the system will help you track all of that, and we can raise alerts where we are going out of the temperature zone, or in for the guest comfort, and similarly for food safety. If the temperature is beyond, let's say, 4 degrees for dairy chillers, or less than -18 for meat chillers or freezers, right? So all of those things can be automated. So I think that's pretty much, I really wanted to, cover today. And I'm just going to talk, give you guys, I hope this session was helpful in terms of understanding that how, IoT is really, contributing towards, bringing energy efficiency, delivering 10 to 20% energy savings, improving compliance, and also helping reduce breakdowns. So before we sort of get into questions, I'll just help you understand a little bit more about Zenatix. So Zenatix is a company, as a company, we provide IoT-based automation and monitoring solutions. Our focus is on delivering energy efficiency and asset management. The company was started in 2014. We were bootstrapped like any other startup at that time, raised some capital from very key and elite angel investors in India, people like Rajan Anandan, who used to head Google India and Southeast Asia at that time. And Snapdeal's founders, UTC's ex-India head was one of our investors. And we raised capital from Bloom Ventures and Pi Ventures like any other startup at that time. And then joined hands with the Hero Group in 2018. Hero, as you know, is a very well-respected brand in India and other markets in the world. We partnered with them. They back us financially, help us grow. And then, so specifically within Hero, we're part of this entity called Hero Electronics. And Hero has this mandate to invest into technology space to sort of build homegrown businesses out of India. And they are investing into connected solutions companies, and we are one of them. Overall, we are about 100 people strong. We have 3 offices in India and 1 in Middle East in Dubai. Overall, we about 2,500 deployments. We have about 50,000 connected assets today on our platform. And these 50,000 connected assets are all air conditioning systems, lighting systems, exhaust fans, diesel gensets. So anything which is related to energy, we have that. And there are about 200 million data points that we receive every day, which help us keep on sharpening our algorithms from an asset management standpoint. So identifying, issues with equipment health, with safety, with compliance, all of that, and more data helps us do that. And we can benchmark across different verticals or different types of air conditioning systems and help you also improve your infrastructure over time. So we work on operational efficiency. And once the operational efficiency is addressed, then you can think about replacing the infrastructure, because otherwise, right now the problem is the other way around. If you talk about energy efficiency, the first thing that comes to your mind is replace your air conditioner or replace your lighting systems, right? I think a lot of people have already gone through the cycle of replacing all of the lighting. But lighting is only 10 to 20% of your consumption, right? The major guzzler is the air conditioning systems, and it's not easy to replace air conditioning systems. So why not to first take the operational efficiency bit? And once you have addressed that, then maybe the next step could be that in a sequence, you identify, really bad air conditioners, from an efficiency standpoint, and replace them first, and do that in a gradual way. So, so as of now, we are operating in India as well as Middle East as key markets, and these are some of our customers. So we work a lot on the retail side. We do a lot of work on the hospitality side. To some extent, we work in manufacturing as well. But our bread and butter is retail. So you see all these customers, which are all enterprise large customers. Domino's Pizza, Pizza Hut, KFC on the food side. We have pretty much all the supermarkets are our customers. And then we work on retail for some of these customers. So that's pretty much, I really wanted to cover today. Let's, happy to, I think we're fairly good on time. We have, sort of, let me just go to the first slide. Let me just, I think happy to answer any questions. There are a bunch of questions that we have gotten there. So over to you, Abhishek, if you can just help with some of the questions, let's answer them.
So the first question is from Ali. Question reads as, how does IoT address different types of HVAC in retail?
Yeah. So so that's a very good question, and it's there is no one solution which can solve all types of air conditioning systems, right? So there are different solutions, and these are the capabilities that one develops over time. If we look at our journey, we gradually, over a period of 5 or 6 years, started different solutions. The split air conditioners can be either controlled over a universal IR or simple contactor relay based solution. The ductable units have their own controllers, which are communicable. They can be addressed through that. The VRV systems talk over BACnet protocol, so you can address them. The chiller-based systems, they talk over a lot of IO modules for which are typically 0 to 10 volt signals or 4 to 20 milliampere signals. So different solutions for different types of air conditioning systems is really, I mean, there is no sort of one size fit all. It's just that I think you have to develop solutions for different types of categories to be able to provide. And that's very important in retail, because a retail customer would have a varied infrastructure, right? Somewhere they're high street, somewhere there are malls. Within high street, they may have split, ductable, VRVs, all types of air conditioning systems. And as a provider, we have solution for all, and that's why we are able to confidently go to a retail customer and say, I can serve across all your outlets. So I hope that answers the question.
So moving on to the next question from Bobby. So why would you need a cloud to connect to do most of the linear logic that has been mentioned, when it can also be done with edge controllers presently available in the market?
Sure. No, certainly, I think, edge controllers can certainly, do the trick, if they are simple controls. But I think, a lot of asset management requires a lot of compute, So, looking at, so I think there are two benefits that the cloud brings in. One is that for an enterprise customer, you bring all their locations onto a central platform to create a visibility across their entire distributed infrastructure. Otherwise, the edge controllers can certainly, like a BMS, BMS does a great job at automation on a on-premise system. But in retail, because you have so many locations, you need to bring them onto a common platform from a corporate standpoint. So that's an advantage of cloud. And secondly, you can do a lot more compute on the cloud. So if I'm getting data from 500 cold rooms or even 50 cold rooms, real-time data, I can't run AI algorithms on that edge, because otherwise the edge controllers will become super expensive. So you have to keep the costs low, still deliver the benefit, and that's where cloud comes in handy. But cloud doesn't mean information security issue, because a lot of people get concerned about it. So we do there are every communication that we have between our edge gateways and cloud is encrypted with 128-bit secure channels. The data is secure on the cloud. We abide by all the information security standards. Even if connectivity goes down, the edge controller keeps on doing the job. So these are the benefits that cloud brings in.
There is a related question again, Bobby, that in what scenarios do you need AI and ML? If you could give any use cases for such scenarios.
Yeah. So I think, the AI ML is really required for asset management use cases. So, I think, if you ask me, everybody talks about predictive maintenance. Now, predictive maintenance is a holy grail, but I think there is a journey to that whole, to that holy grail, because, there is no easy answer, right? So but I think at the same time, there's a lot of low hanging fruit. For example, I took the example of a refrigeration or an air conditioning unit. How do you, look at their temperature compliance vis-a-vis the duty cycling, right? Now, the duty cycling has to be done in relation, the understanding of the duty cycling or the modeling has to be done in relation to the outside weather. So if the weather outside is cooler, you will have more cycles. If the weather outside is hot, you'll have lesser cycle. So you don't want to raise a false alert. So you have to look at rolling averages. You have to look at a lot of data, different slicing and dicing, to be able to sort of say that, look, I'm maintaining the temperature, but I have an issue with the thermostat or I have an issue with the compressor. and I got to raise the alarm, because if I raise wrong alarms, the customer will lose confidence, especially the ground team, because the ground team will say, look, why are these guys throwing false alerts, right? So that's where I think you need compute, a lot of understanding of these systems from an electromechanical standpoint to be able to deliver value. There could be other examples of, let's say, current unbalance on phases of a motor, right? So how do you of an induction motor, right? That will eventually lead to breakdown of the motor because one of the windings may be wearing out. So there are probably several of these examples that we have gotten.
Over to the next question. This question is from Aisha. So she asks that typically wireless technologies seem to be more costly compared to the wired ones. But how are they on the resilience of connectivity? And what is Zenatix using currently in terms of technology to solve for the wireless?
Sure. Excellent question. I think, there is, I think that's how, people talk about resilience, people talk about cost, and people talk about, state-of-the-art technologies. So I think, resilience and cost, so let me just straight away answer the question. We use, open thread mesh, which is, a layer developed, basically open thread is developed by Google. If you are familiar with mesh technologies, there is OpenThread, there is BLE, there is Zigbee, really the three low power mesh which is available out there. So OpenThread is something which is outsourced by, open source by Google. This was in the Nest thermostats when Google bought Nest. They open sourced this technology, and then we built a layer on top of it to do device management and everything. Now, the resilience is very high in a mesh technology. In a wire, we traditionally used Wi-Fi, where you have these connectivity issues, and that's why we eventually over time moved mesh, because mesh is a lot more reliable, because there is a self-healing mesh. So if you break connectivity with one node, there is another node in the vicinity, you connect to it automatically. That's the nature of the mesh. Cost, I would say that over a life cycle value, there is a lot. I think, if you just look at if you compare the cost of a wired temperature sensors with a wireless sensor, yes, a wired sensor will be cheaper. But if you add the cost of deployment, which is the wiring, the commissioning, and then maintenance of that wire over a period of time, and especially in the emerging markets where there is a lot of dust, heat, these wires are very, very difficult to maintain. So I think in the overall cost perspective, wireless is much more cost efficient. So one should not really compare the cost of the module, but the overall cost of deployment and management as well.
Moving on to the next question. This question is from Shrikant, and he asks, how will the solution help an electronics or a fashion showroom?
So electronics in a fashion showroom, I think, again, in these showrooms, there is a lot of air conditioning and lighting, right? I think lighting, significantly used in these showrooms as well. So I think just, control of air scheduling and maintenance of right temperatures, can just simply deliver. It sounds very trivial to say that, you're just, modulating the temperature and you're just switching on and switching off. But doing that at scale delivers easily 10 to 20% energy savings. I mean, that's our experience working with some of the customers in this area. We work for fashion customers, we work for electronics customers.
Sure. So go to the next one. Bobby compliments on the presentation and found it useful. And then he adds that if you could clarify what kind of data does Zenatix capture, and the 200 million data points that you talked about, what are they typically and what is done with them?
Sure. So all of this data. So first of all, from a customer standpoint, this data doesn't breach into any of their confidential information, right? So we are staying fairly outside the network. The connectivity that we use from the gateway to the cloud is all sort of GSM in most of the cases. But it's all electrical comfort, asset related data. So there are really three broad assets. There is energy related data. You look at power, current, voltages, power factor, energy, apparent energy, reactive energy, all of that, right? And it's all sort of collected in real time, which obviously generates a lot of data. But because it's all real time, we can identify the trends and anomalies in that data. There is comfort or environment related data, temperature, humidity, um, CO2 levels, AQI levels. So that's another thing that is slowly, gradually catching up, that how do you manage air quality in these outlets, because there is a lot of focus on air quality. So I think that's what it is. And then, equipment related data, the health of the equipment. So again, this is all derived from the power related parameters. We typically do not get into the equipment, which is also going to raise warranty issues. So we typically stay outside unless it's a standard O protocol, like a backnet and a VRV system or a BMS. If we are interfacing with a BMS, in some cases, we do a lot of work on the commercial building side, large buildings as well. That's where we do, but that's all data. And then we use this data to deliver asset management algorithms.
The next question is from Jiju Anwar. Is what the edge devices that Zenatix uses? What the designer? What is the make, brand, and country of the origin of devices?
Yeah, so these are all made in India devices. We have our own design. We decided not to take a standard off-the-shelf gateway because we understand the challenges of a developing world. There are power issues, power failures happening. There are voltage issues. There are connectivity issues. So how do you develop a gateway? For example, while I can fetch the time server, time data from a time value from a time server, if I don't have the connectivity, what do? I need to have a real-time clock on the system. I need to have enough processing power that if the power failure happens, after the power failure, how do I manage the current situation? If there is no connectivity at that time, what do I do? So these are all the things that we learned over a period of time, say 6, 7, 8 years, that we have been able to reach to be able to say that, look, I have 50,000 assets connected to my systems today, and how do they work in a seamless fashion? So this is all designed by us, managed by us, developed by us, and it's all made in India.
The next question is by Faz. Question reads that typically the IoT solution that you talked about, what is the kind of ROI time frame that you would expect the solution to give? And how is the ROI very tangibly measured at a customer premise?
Great question. I think the straight answer is, we've seen ROIs under 12 months also, because it's all a function of how much wastages are happening. I think the range that we have seen in energy savings is a fairly wide. On the lower side, it's about 8 to 9%. On the higher side, it's about 14 to 15%, or sometimes even higher. And the ROIs we've seen mostly in the 12 to 15 month range, which is very, very quick. And sometimes, as I said, less than 12 months. How do you measure it? From the energy bills. You compare, it's visible in your energy bills, how, this October's bill versus last October's bill. Or you can simply say, I deploy the system, I just do benchmarking before I put my controls. We deploy controls, again, do the benchmarking, and you can simply see a visual difference. And because we are deploying energy meters, it's essentially easily visible that yesterday you spent 2,000 units, today you spent 1,800 units of electricity. So it's very, very tangible. And that's how most of our customers have scaled up with us, because they could see this tangible difference in their energy bills.
Next question is, how can Zenatix help in dynamic operations in environment. For example, for a warehouse where there are multiple operations taking place simultaneously, and the operation is 24 cross 7.
Sure. So I think, it's essentially the IoT allows you to manage complex multiple operations, because then you can, the system, you can define how an operation can happen at at an equipment level. So if there is a lighting in a certain aisle, or if there is an air conditioning in a certain area, you have an office area, you have a warehouse area, how do you can define at an equipment level that, how do I really want to run it? Based on an input sensor value, based on a schedule, or based on any other parameter. And because it's all connected, you can also change the rules centrally, right? Without us or your team to be actually be present at the site and fiddling with the, equipment. Everything is centrally controlled and centrally managed. And you can define at an equipment level that, how do you want to control it?
The next question is the two questions actually I would like to club them in one related question. So what is the typical revenue model that such IoT solutions follow, and how is it different from an ESCO model?
Yeah, so I think the ESCO models typically work well, when there is a significantly heavy investment. And then, you have third-party financing, and you do a energy saving sharing model with the customer, right? Because the customer can't afford to spend. IoT solutions are, if you compare a replacement of air conditioner or setup of a solar, that's where ESCO models make sense. When you're looking at IoT solutions, they're fairly cost effective, which basically means that the customer directly invests based on a fixed fee model. And they can get ROI within 12 to 15 months. So you can use so we, for example, you charge upfront for the hardware that we deploy, and we'll charge a recurring fee for the software services and the infrastructure.
The next question is that many anomalies do appear because of the malfunctioning of equipment in the building, but there are also scenarios where the anomalies or the faults are seen due to bad design of let's say the HVAC in the building. So how strongly can such an IoT system identify those anomalies which are, let's say, occurring due to design, and what does it do to address them?
Right. So I think, that's, what is IoT allowing you to do? It allows you to deploy sensors wherever you want. It allows you infrastructure to process that data and identify those anomalies, right? Now, you're right that, a lot of places there could be HVAC design related issues. For example, let's say, take an example that in a typical store, if you say that, I want to design a store and put, 1 ton of air conditioning for every 125 square feet. Actually you ended up doing one for every 200 square feet or 125 square feet. Or there is a refrigeration heat ejection happening within the store itself, and that is creating a problem. Now, you can triangulate the data. You can actually see the set temperatures, and you can see the return air temperatures, and you can also see the supply air temperatures, because so you can see that, look, I have a sufficiently cool supply air temperature of 12 degrees, 14 degrees, or even 10 degrees. I'm still not able to achieve the set temperature of 24 degrees because it's a poor design, right? Or you can actually say, if it's a long duct, you can actually deploy sensors at multiple levels, and at the farthest end of the duct, you can always sense the temperature and say that, look, the temperature is not being maintained, right? So I think you can easily identify problems related to design or operations, both. And which is what example I was taking, that, That's our expertise, that will keep on building this repository of use cases for various customers and then keep on improving ourselves over a period of time. That's the beauty of the data.
So I think there are a host of other questions, but we have hit the end time for the webinar, Rahul.
How many more questions we've got to go?
We have 3-4 more questions.
Let's, I think, quickly run. I'll just try to be efficient. I think, or people can just always contact us offline.
Yeah, so, yeah.
If there are only 2-3, let's just quickly run through them.
Yeah, I'll also club the related kind of questions just for ease of comprehension. So one more question from Bobby is around fault detection and diagnosis. Wants to understand, what does Zenatix exactly do in the fault detection and diagnosis area?
That's hard to answer, because fault detection and diagnosis for us is use cases, right? So now you can define n number of use cases. You can say voltage drops across different panels. You can say power factor issues. You can say duty cycle issues. You can say current unbalances. You can, so n number of such use. So FDD is actually not one thing. FDD is like, probably we'll have 50 to 60 or 70 use cases which we have identified with our experience on electromechanical side, and that's where we'll marry electromechanical expertise with the data to address FDD.
Then the other question is around type of logic that is used. The question goes, most of energy management can be done by basic linear logic, and how does Zenatix approach it, and what are the different kinds of...
Yes, it sounds like linear logic for control, yes, but linear logic becomes super complex when you have corner cases, when hundreds of sites are deployed. So, and I think that's where you need to have expertise around those, addressing those corner cases, even for us to apply linear logic. And yes, linear logic can give you the low-hanging fruit in terms of immediate energy savings, but then you use the data to keep on improving year on year for the customer from an asset management standpoint. And that's where the value is really.
I think we are good with all the questions now. The last couple of questions are a repetition, which have been answered.
Perfect. So and guys, feel free to, there's going to be survey form. Please fill that survey form. Happy to schedule calls separately with you. Our team can do that. And please feel free to include your questions there also. Please reach out. I'm so glad that you guys have been very, very participative audience and asked a lot of right questions. So it's a pleasure again. You guys have a great evening and a great weekend ahead, and talk to you guys soon. Thank you.